Hello, and welcome to this film, which is an introductory film to the acids and bases topic in the standard level IB Diploma course. And hopefully, by the end of this film, you'll have seen some of the key terms that we use quite a lot in this topic, and in particular, you'll be able to define what we mean by an acid and a base in terms of a particular theory called the Bronsted-Lowry theory. And also, by the end of it, you'll have seen a number of different important acids and bases that we need to know about. And in particular, we'll focus on some acids that have different numbers of protons in them. Okay, so to begin with, let's have a look at some theories of acids and bases which you might have used up until now, even if you didn't refer to them as theories of acids and bases. Okay, so you might have seen this thing called the pH scale before, and the acids on the pH scale have pHs of less than 7, and bases have pHs of greater than 7. You might also have used this chap's theory, the Arrhenius theory of acids and bases. You might not have called it that, but you might have been aware that acids are solutions with H plus ions in, and bases are solutions that contain OH minus ions. So that's Arrhenius's theory, and it's one that's useful, but one that we're not going to use so much in this topic. And you might even have done the periodicity topic by now, in which case you know that metal oxides tend to be basic, and non-metal oxides are acidic, and there's these kind of in-between oxides which we call amphoteric. So that is acidic and basic. What we're going to do now is we're going to introduce a theory which is the one that we're going to rely on most in this topic, whether it's the SL acids and bases topic or the HL acids and bases topic, and that is the Bronsted-Lowry theory. Now this theory is all about H plus ions, okay, and according to this theory, we can define an acid as something that gives H plus ions away. Now, an H plus ion is just a hydrogen atom that's lost an electron, or in other words, it's a proton. So another way that you hear acids being defined is proton donors. So things that give away H plus ions or donate protons. Okay. On the other hand, bases are things that accept protons or take H plus ions away from other substances. All right, so there's our definitions of acids and bases in terms of the Bronsted-Lowry theory, and it's all about H plus and whether you give or whether you take. Now here are some important acids. When I say important, it's important that you know their names and their formulas. There's lots and lots of other acids that are important to us, I suppose, but not ones that we have to remember the names and formulas of for this course. So here they are. I'm not going to read them all out because you can just pause the film and make a note of these. But it is important to realise that they've all got H in them. And perhaps that's not surprising considering that all acids in terms of Bronsted-Lowry theory are proton donors or H plus givers. Okay, I've also got non-metal oxides here. I've put it in brackets because if you're a non-metal oxide like carbon dioxide, and obviously you don't have H plus to give away, but when these things dissolve in water, they turn into substances that do have H plus to give away, and that's something that we'll look at a little bit in the future. Okay, here are some important bases. And again, I won't read out the whole list, but what you might be able to see is that a lot of them have got this thing in common, which is, as we've heard in the Arrhenius theory, that bases have OH minus ions. But there are other substances as well that don't have OH minus ions, like ammonia and like amines, which you won't have heard much about yet because they're in the organic topic and you might not have done that yet. Okay, but ammonia is certainly important, something you should be aware of. Amines will be important by the time you've done organic chemistry. Metal oxides, again, right? These are things which will accept H plus ions. So all these things accept H plus ions, and it's important that you know their formulas. There aren't so many as there were with acids, but sodium hydroxide and potassium hydroxide are really common bases to come across, and so is ammonia. But all metal hydroxides, except for the amphoteric ones, which we, again, don't need to know very much about, are bases. Okay, now just to finish up with, we're going to look at the difference between a monoprotic and a polyprotic acid. Now you might have seen earlier in this list of important acids, which I haven't got all of here, I've just got some of them, the H's were underlined and different ones had different numbers of H's. So hydrochloric acid has only one H plus ion. Sulfuric acid has two. Phosphoric acid has 3, right? So a monoprotic acid is one that only has 1. A polyprotic acid is one that has more than 1. Sulfuric acid would be called diprotic, and phosphoric acid would be called triprotic. Ethanoic acid looks like it might be a polyprotic acid because you can see 1, 2, 3, 4 H's in it, but only one of these can be given away, and that's why it's called a monoprotic acid. So not so important for now that we can kind of understand why this is, okay, but it is important that we understand the difference between a monoprotic and a polyprotic acid. Okay, so that's it for this film. We haven't covered all the key terms in the topic. There are some other ones which we'll come across as we go through the films, but hopefully it all makes sense up to now. If you've got any questions or comments, then please feel free to come and see me or to post a comment on YouTube.